Hey guys, my name is Zakil and welcome to btech YouTube channel. So you might have well known before me like posting this video. This is regarding the Infosys specialist programmer role. So most of the candidates have written the test today between 11 to 2, and what I felt like the questions are really hard. So hard to very hard level medium of questions have been provided, and there are few candidates who received um, uh, like average kind of thing. Okay, average medium questions, those were lucky to by solving them. So but few of the candidates have really got all the dynamic programming questions only. So now I will be taking you to few questions where we felt like okay, these are the questions we can solve. So there are bunch of questions that I've received from different various candidates regarding the solution. But Infosys really gives the tough questions for everyone, either you're fresher or the experienced candidate. So they will be coming up with their own questions, which are really tough to solve them. But what we have done is in the morning, so we have tried our level best to make sure we complete each and every test case provided. So here are the six or seven which I brought you for today questions, and remaining questions I will be posting in the description box. Like I will be creating a Google document. Okay, I will be posting all the images as well as the questions what they have asked so far. So in case if you want to go through those document, and in case if you want to prepare yourself for the next kind of next Infosys exam, you can just prepare from those questions. Okay, so I'll be doing that later. So for now, let us explore what are the questions they have asked. Okay, and this is what I made for today, Infosys specialist programmer role. So this is the exam which we are going to discuss now. Okay, so let us see the first question. So the few candidate, one of our candidate have got these questions: permutation swaps, flip the brackets, and k occurrence in counts. So all these are easy, but when we try to solve this, like most of the programs have executed only these sample test cases, and few programs have done with the test cases like around 7 to 8, and few sample test cases. So all the programs that we have done are only, most of them are only sample test cases were passing, but none of them have really passed entire test cases. That is really weird. Okay, so let us see the first question: permutation swaps. Here you go. So you are given a permutation P of length n. This permutation represents a graph of n nodes where for each node I from 1 to n, there is an ongoing edge from the node to P of I node. Okay. A permutation is an array of length n considering of each of the integers from 1 to n in some order. The longest path in the graph is the path that satisfies the following conditions. So here are the conditions that we need to make a note when we are writing the code. Okay. It starts from some node u and ends at some node v. So any node, it should be either u or v. It visits every node no matter no more than once. Okay, it visit only one node but only once, each node at only once. Among all these possible paths, this is the longest one. So among all the dots, which is the longest one. Okay, so find the total number of possible pairs of indices of the permutation I comma j such that if p of I and p of j are swapped, then the resulting graph has the maximum possible longest path among all the possible swaps. So in case if you or in case if you shift the nodes between each other, so the entire path line should be the as longest among all the each other. So that's the question they have given. Since the answer is very large, print in the module of 10 power 9 plus 7 that we will be writing in the code. Okay, no problem. So input format, the first line consists an integer n denoting the number of elements in P. Each line I of the n subsequent lines where 0 less than equal to I less than equal to n consisting an integer describing P of I. Okay, so P of I value should be in the range of uh, 0 less than equal to I less than n. Okay, so sample test case here, see 3 1 2 3, they have given. So 3 is the number of nodes and 1 to 3 is the nodes, and the resultant output is 3. So let us see the explanation by. Here you go. So here if we swap p of I, p of 1 and p of 2, we will be getting p is equal to 2 1 3. Node 1 can go to the node 2, and we can consider that the longest path. Okay, so node 1, which means 2, can go to the node 2, which is 1. Okay, so can go to node 2, and we can consider the longest path, and also node 2 can go to the node 1. So we also can generate the following two permutations: 3 2 1 and 1 3 2. So the answer is 3. Okay, so that's how they frame the entire uh, what we call permutations. Okay, so let us see the second one. 6 2 3 1 5 6 4, the result is 9. So there are 9 possible ways that we can do this permutation given. So hence we have two circles. The nodes in the first cycle are 1 2 3, and the nodes in the second cycle are 4 5 6. So 1 2 3 and 4 5 6. And here you go with the remaining explanation. So here we have two circles, the node. So we have completed this. So we can show that if we swap any of the first three elements in the permutation, excuse me, so with an element from the last three elements, the circle will be merged. So the answer will be 3 is to 3 is equal to 9. So in case if you reverse all the values from one array to another array, which means like equal multiplication, which will be 9. Okay, three elements into three elements. And here with another one, 1 2 3 and 4 5 6, same. Okay, now we need to find the maximal. So 3 into 4 is equal to 12. So as simple as that, guys. So once you understand the logic, like, it will be easy for you to write the code. So let us see the code for this. Okay, I need to explain. Okay, so here you go. So permutation swaps. So let us declare the modulation operation. So the get answer is a function definition that they have already provided. Okay, we don't need to rewrite it again. Okay, and then here you go with the main logic. So user array I've defined. I have used another function called get user array of p. So p is nothing but the array that we have getting. Okay, so now this user array will be passing the p and it finding the length and visited nodes. False user array I've declared another array. So where I will be iterating over the each and every array, and then I will be swapping all the values here, like, and also I will be counting them. Okay, so count swap is the function I declared. Okay, so that's how I'll write. So I won't explain much of it details, like, these programs which we have done, which we have sent to our fellow beings. This code, especially this code, I've passed around 4 test cases, I guess. Okay, so I won't detailedly explain you. Okay, because if I go on detailedly explaining it, it's waste of time because it doesn't execute all the test cases, right? So I don't want to go into much details, but in case if you want to have the basic structure of the entire code, we can go through this. Okay, I'll be making a little zoom out so you can make a note of this program somewhere in your system, so you can take a screenshot if required. Okay, let it be keep. So let me zoom. Okay, so this is a code. It's around medium level question. Okay, it doesn't take much time to solve, but we felt like we are able to do all the sums, all the test cases, but somehow we couldn't manage to solve all the test cases. Like, it's around how many, 3 10 plus 3, 13 test cases. Out of 13 test cases, we only passed 4 test cases for this program. Okay, so just make a note, I'm telling what are the test cases that are passed from the program. Okay, then in the comment section, don't ask me, don't post unless and then all the test cases were passed. Okay, so just this is just to make you sure that how the programs were asked and how many lines of code that we are going to write to solve a certain problem. Okay, as simple as that. Okay, so let us see the another one. So that's the first program, and the next program is the flip the braces. Okay, so you are given a brace, a bracket sequence s of length n consists of two characters, open brace and curly brace, and the number k. A bracket sequence is called regular if it is possible to obtain a correct arithmetic expression by inserting characters plus and 1 into the sequence. For example, sequence open brace, close brace, two open braces, two close braces, open brace, close brace, and excuse me. Hope you understand this sequence. Okay, so let us move that. Okay, you can do the following operations at most k times. Choose an integer, sorry, index I, 1 less than equal to I less than equal to n, and flip the bracket at the ith position from open brace to the closed brace and from closed brace to the open brace. Okay, so they are asking you to choose any index from the entire brace list. Okay, so find the number of ways to make the given bracket sequence regular. So what is regular? If we can possible to find a correct arithmetic expression by inserting characters. So by inserting characters, if you can make a correct arithmetic expression, that is called regular expression. Okay, as simple as that. Okay, so let us see the following test cases. Okay, let me go. So the input is 1, input is 2, and 1 they have given. So I have used the braces as open brace and curly brace. The sample input will be 2, I guess. Answer should be yeah, 2. So why 2? Here you go in the sample. We have the change either the second brace to the obtain, uh, so open close. Okay, and the third one open close, and both of these are regular. So guys, we can insert all the values. Okay, so that's why they are called as regular. You can do comparison operation and then you can solve. Okay, and then the for sixth third test case, here you see 6 2, they have given 1 2 Oh, okay. Two open braces, two close braces, one open brace, close brace, and we got the result as 4. Why? Because so all the possible regular bracket sequence we can obtain are following. So close and open, which is 1. So like this also we can write, so we can use precision 1 2. Okay, so in this manner also we can do the arithmetic expression. So in this manner also we can do the arithmetic expression, like we can declare an expression in between them and you can solve. So the answer is 4. Okay, so here is another case. So 4 1, here you see they have given open, close, close, close. So what will happen here? Only will be getting 2, because we can either use this one or you can directly replace there. Okay, so I think we are missed from there. Okay, but the just go with the explanation. Okay, don't worry about this. So also code for this again. So here you go. This count sequence and flip the braces. So this is the code one of a candidate have sent, because one of the candidate have sent. Okay, so they have used DP, dynamic programming kind of array and list. Okay, so I'll be pausing the video for a few seconds. You can make a note of it. Okay, you can run the program runs. Okay, don't worry. Okay, 1 2 4. um, so the code which I'm showing is already runs the sample. Every program which I show runs the sample programs. Every program will execute sample programs, and there are few programs where I will be telling you number of test cases passed for that. Okay, don't worry. So this program, I guess, it only passed the sample test cases. Okay, so this is sent by the one of our fellow group members, so I didn't decode something. Okay, but just make a note. What I'll do, I'll show what the code which I've written, so you can map. So yeah, they have used dp of dp. There is a list of list. Okay, I think I have written somewhere. Okay, so this is the code I've written. Okay, I didn't take most of the time, like it's around 30 minutes they have given and asked me to write the code, so I've used q to implement that. So that's why I gave me. Okay, so 214, that's the expected output we'll be getting, so from the question, from the test cases. But I really don't know the how many test cases will execute for the code which I've written, because when our candidate is writing, like it's time is almost done, like I have sent around 15 minutes before. So she or he was unable to write the code in time. So like, so this is the code which I've written. I'm not sure how many test cases will be getting passed for this, but it all executes for the sample test case, that I can say. Okay, so this is a code which I've written. You can make a copy of it or anywhere. Okay, so I won't explain you much details. Like in case if you need any explanation, just shout out on my Instagram handle. So there I will be explaining you. Okay, fine. Okay, so let's just see the another test case. Sorry, another program. So this is the k occurrence counting. Okay, so you are given an array a of length n and the positive integer k. A subarray is considered good when each element present in the subarray appears either k times or zero number of times. Find the number of good subarrays present in A. Since the answer can be very large, modulo 10 power 9 plus 7. Okay, the first line consists an integer n, denoting the number of elements. The second line contains an integer k denoting the given integer. Each line of I of the n subsequent lines where 0 less than or equal to I less than or equal to n consisting contains an integer describing a of I. Okay, so that they have given, and here you go with the test cases. So 5 all ones, the result is 5 because each subarray of length 1 is good. So hence the answer of the case is equal to 5. And here you go with another thing. So 500 10 1 3 5 2, the output is 0. So there exists no good subarray excuse me, subarray in a, hence the answer for this case is equal to 0. Okay, so let's go to the another one. So 5 2 5 5 2 3 2, the output is 1. So there is exist only one good subarray in A. Okay, so that's how the entire question is. I think messed up something, so let me explain here. Okay, a subarray is considered as a good when each integer present in the subarray appears either k times or zero number of times. Okay, so they are telling like each integer present in a subarray, like in case if we split the array into subarrays, there should be k number of repetitions of an each and every integer. Okay, so that's we need to make sure. In case if you find, that's the you need to count it. Okay, so let us see the key occurrence program. Yeah, here you go, the key occurrence program. I'll be running this program for your sake. Like 510, we need to get 510. Yeah, so yeah, I'll be pausing the video for a few seconds. You can make a note of it. So for this K occurrence in code, from around 13 test cases, we have passed. I think only 4 test cases. Total. Total 9 test cases were passed for this program, including the sample test cases. Total 9. Okay. So I don't know. Okay. What happened is like the time limit of okay. So for this program, I guess permutation swaps time limit exceeded. Okay, and the program, which another program is flip the braces. So we have exceeded the time limit for the program execution. So that's why the program fails to execute. Okay, this one also I don't know why. Like few test cases were timed out, and few were like I don't know. Mostly like for this program we got around 9 test cases were passed successfully. Okay. Just make a note somewhere, that will be helpful. Okay. Oof. Let's just see the another one. Okay. Okay, currency is completed. So the next one is string comparison. So you are given two strings L and R of size n. Okay. Doesn't make a problem. Okay. Okay, so find the number of possible string s which satisfy the following conditions. It is lexicography greater than or equal to L. It is lexicography smaller or equal to R. The bitwise and of the occurrence of characters present in s is equal to 0. Since the answer can be very large, written in the module of 10, 10 power 9. Okay, let us see the sample test cases, and here you go. Input 1 a, the result should be 0 because n is equal to 1, L is equal to a, and R is equal to a. There exists no string s that satisfy the conditions, since the answer for the case is equal to 0. So what are the conditions? The lexicography greater than or equal to L. Okay, so it should be greater than or equal to L, and the lexicographical smaller than or equal to R, and bitwise and of the occurrence of character present in S is equal to 0. Okay, so these are the three conditions that we need to satisfy. Okay, so input to a b. So answer is 1. Why? So n is equal to L is equal to ab, R is equal to ab. The string S is equal to ab satisfy the given conditions, and hence the answer for the case is equal to 1. Okay, so sample test case 3, here you go. So ab 2. So n is equal to r, L is equal to r is equal to 80. The string ab and aj satisfy the given conditions, and the answer for this case is equal to 2 because it satisfies two conditions. Okay, so let us see the code for this also. Flip the brace, not string counting. Okay, so I think it have executed the four test cases out of 13. So I won't explain you details, but just make a note. Okay, when you encounter this kind of questions, you can use the structure code. Okay, so this is how we need to solve, so this is how we need to write ordering and everything. Okay, I'm not saying like the code which I've written is correct, because programmers, we are programmers, we do mistakes. So we use different logics to encounter a problem. Okay, but what you need to do in case if you find any mistakes in someone's code, just give a shout out like, okay actually here I think you need to consider this, and so that's how we each other learn something from our mistakes. Okay, so in case if you find, in case if there is an enhancement in our code, just give me a shout in the comment section like, this is the code I've written, what do you think of it? So I will be executing all the sample test case, and I will be say like, okay, you have done a good great work. Okay, so that's how we should learn each other. Done. Okay, so let us see the next one. So abc string, I think this is the abc string. We need to count the number of string s of length n that uses the letters a, b, and c. Additionally, s should not be contain the string abc as substring. Okay, very simple program guys, very simple program. So they say are simple saying like, we need to count the number of string s of length n that only uses the letter a, b, and c. Simple. Okay, so for one we need to be returning 3 because there are three strings a, b, and c. All of them does not contain abc and substring, so the answer is 3. Okay, so for 210 we'll be getting, I think this is separate, this is sorry, this is another question, another test case. So for 3 we need to be getting like 26 because n is called 3, there are 26 strings in the total. Only one of them contains abc and a substring which is abc, so answer is 227 minus 1 is equal to 26, like a, ab, abc, abc, ad, ad. So that's how we will be calculating each and every letter. So 20, so this is the number, a huge number. So there is 674922943 strings that does not contain ABC as a substring of 20. length. Okay. Done. So let me show the program for this ABC less case. So here is the program. So let me run this also. So 326 and 6749437. Okay. I think this program I have passed around 9 test cases. Okay. Very simple. Okay, very simple program, but you need to understand the logic behind it. Okay, so don't worry, these are all the basic what we call base conditions that we need to write for each and every program. Okay, so base conditions and then action logic. Okay, done. So let us see the another test case, another program. Done with the string comparison ABC string, and here is go with the. Okay, let me go to the first one. Okay, increasing miss. I think I have missed the eating part of the question, but let us see. Let us see samples. Okay, I think it won't make sense if like showing test case and explaining you. um okay, let's see. 2102, the given is n is equal to a is equal to 1 of 0. The way of making the array good is 1 of 0, the mixer is 2 and it's non-decreasing. 1 and 0, the mixer is 0 comma 1. So we have 2 and then 3. So 3 we can make a array good as 0 0 0 0 0 0 0 1 0 0 0 So that's how we can split the entire array. So here you go with the 6. So we can make 6 easy like 0 0 every each and every element, and then separation of elements, 3 elements, 4 elements, 5 elements, 6 elements. So that's how we can split. So number of elements is called number of arrays. Okay, so for this code we also have written the code for that. I don't have the main image to explain you the logic. Okay, but this is the program. Or okay, so this is the program, so I can run for you. 642, so that's the required output. So this is a mixed number program. Okay, so I'll be pausing the video for a few seconds, you can make a note of it. So for this question, I guess it's passed around 3 test cases of on 13 test cases. Okay, um simply nice. Okay, so I think these are the questions that I bought you for today, but I will be posting a Google document link in the description box later. Okay, what I'll do is like I'll be making a note of each and every questions there, and in case if you want to go through those questions, you can go through them and just prepare yourself for the next Infosys questions. I can simply say that the questions are really hard and very hard level questions. Okay, so basically it will be difficult for us to solve also. In case if you are well prepared with the data structures and algorithms, then only you will be able to solve these questions, or else like you'll be getting a deck. mm, Simply. Okay, so that's it for today guys, and I'll be posting all those in the description box by creating a Google document as I mentioned. And before that, don't forget to subscribe our channel after watching this video. That's it in this video guys, and let's catch up in another video. Till then, have a nice day. Bye bye.